What up, physical science freshies? I'm here to explain how to do some energy calculations, more specifically, energy calculations related to kinetic energy, gravitational potential energy, and also mechanical energy. And then there will be another energy in here that is called thermal energy. And thermal energy will just be the amount of energy lost. So if you start off with a certain amount of, say, gravitational potential energy and you end up with a certain amount of kinetic energy, the difference between the two would be the thermal energy. It would be the energy that's lost through whatever the situation is. So, in order to do these problems, what you need to do is at the top of this worksheet, when you open it up in Google Classroom, you need to write these equations down. We have GPE, which is gravitational potential energy, is equal to mgh. M is mass, g is the acceleration due to gravity, and so g is going to be equal to 9.8 meters per second squared. And then h is the height. So just remember that. GPE is gravitational potential energy, m is mass, g is acceleration due to gravity, which is 9.8 meters per second squared on Earth, and h is the height. Now kinetic energy, kinetic energy is equal to 1/2 mv squared. And so kinetic energy is Ke, and the m here is mass, once again, and v is the velocity squared or speed squared. And so those are the two specific equations for your two energy types that you'll be dealing with here. And then one thing I do want to point out that me, which is mechanical energy, it is the sum of your gravitational potential energy and your kinetic energy. And then, as I stated before, if there's any questions about thermal energy is how much energy is lost from what you had at a beginning of a situation, and then if the energy changes form to something else, saying going from gravitational potential energy to kinetic energy, if there's an energy loss, the thermal energy would be that energy loss. And that's when friction comes into play. If there's no friction, then you don't have to worry about thermal energy. So I was looking through these problems trying to figure out a good one to show you how to do, and I actually want to go to the bottom or the end of the worksheet, and you have to do a lot for this problem. You have a roller coaster, which is very popular when you're talking about energy and physics. And in this problem, you'll have to do various things. You'll have to determine the potential energy, which is the gravitational potential energy. So this is GPE. You'll also have to calculate the kinetic energy, which is Ke. You'll also have to calculate the mechanical energy, which is Me. You'll have to maybe calculate the velocity, which is V, and you'll also have to calculate the height, which is H. And so you'll have to do some of those for each part. And you'll notice on the roller coaster you have a roller coaster where something starts at the beginning, where 1 is, which is over to the left here at the top of this ledge or whatever. And then the object, the roller coaster, goes down the hill and goes into this loop-de-loop and gets to number 2, which is at the top of the loop-de-loop. And at the top of the loop-de-loop, it's at a different height than it was from the top of the hill that it left from. And then it continues through the loop-de-loop and goes to 3. And 3 is at the very bottom, where there's no height. And from 3, it goes up a hill. And up that hill, we don't know what the height is, but we know how fast it's going. So at the various places, you're going to have to find things. So going from 1, going down the hill, going down the hill, going through the loop-de-loop, going through the loop-de-loop, and then from 2, you're continuing to go over the loop-de-loop, and then back down, and then 3, you're still moving along, and then you go to 4, and then after 4 we don't care because we're going to just solve things going to 4. So in number 1, you have to find 4 things. You have to find PE, which is gravitational potential energy. And so let's, before I write the equation there, let's figure out what we know. Well, we know that there's a mass equal to 50 kilograms. So as you can see, I'm kind of doing the guess method here. Sorry about that. We're at a height of 4 meters. And at the top, we're going to assume that the velocity is 0. And that's all we know. So from that, we want to find potential energy, gravitational potential energy. We want to find kinetic energy, and we want to find mechanical energy. And it also says we want to find V, but we know that V is 0 at the top, so we've already found that. So for the gravitational potential energy, we have GPE is equal to mgh. Well, we know what m is. It's 50 kilograms. And we know what g is. It's 9.8 meters per second squared, because we wrote that at the top. Don't forget it. And then the height is 4 meters. And when we calculate those things, we get an answer of, oh boy, I should have calculated this ahead of time. I forgot. Let me do the calculator really quickly here. 50 times 9.8 times 4 is 1,960 joules. Okay, and now it says to find the kinetic energy. Kinetic energy is equal to 1/2 mv squared. And we know that the mass is 50 kilograms. We know that the velocity is 0. So that means the kinetic energy also has to be 0. And then the mechanical energy is going to be your gravitational potential energy plus your kinetic energy. And that's going to be equal to 1,960 joules plus 0 joules, which is equal to 1,960 joules. So I'm going to let you in on a little secret here. Your mechanical energy is the total amount of gravitational potential energy and the total plus the kinetic energy. Seeing that all we have is gravitational potential energy at the top here, and the gravitational potential energy is equal to the mechanical energy, we will never have more than 1,960 joules, and because we have no friction, the mechanical energy will be 1,960 joules every time. Now we also said that velocity was 0. So if you're putting in numbers down here, 1,960 joules, 0 joules, 1,960 joules, and then 0 for the velocity. All right, so let's work on number 2. I'm not going to do all of this. I'm going to let you do probably parts 3 and 4. So the mass, once again, is 50 kilograms. The height is 3 meters, and that's kind of all we know, but the one thing we do know is mechanical energy is equal to 1,960 joules, because it's going to be the same for all of them. And so ultimately we need to find GPE is equal to I don't know why my hand keeps making this move. Kinetic energy is equal to mechanical energy, which we know is equal to but these are things we're trying to find, and then the velocity is equal to and we actually don't know that this time. So in order to find the GPE, it's equal to 50 kilograms times, hang on, let's write the equation out. M equal to mgh, which is now going to be equal to 50 kilograms times 9.8 meters per second squared times the height, which is 3 meters. And by the way, this thing went through a loop-the-loop. It went from one, it went all the way through the loop to the bottom and then back up to the top. We don't care about what it does in between. We just care that it's at a new height. And in doing so, our answer is 50 times 9.8 times 3 is 1,470 joules, which means we can put 1,470 joules here. We know our mechanical energy is 1,960 joules. And we know that mechanical energy is equal to gravitational potential energy plus kinetic energy. And this is how we find kinetic energy. We plug in 1,960 joules for mechanical energy, and it's going to be equal to 1,470 joules plus KE. And so then KE is going to be equal to 1,960 joules minus 1,470 joules, which is equal to 490 joules. Correct? I just did that in my head. Yes. And so I'll put 490 here. Awesome sauce. And then we've got to find velocity. Well, we know that kinetic energy is equal to 1/2 mv squared. And let's plug in numbers here. We know 490 joules is the kinetic energy. And we know that the mass is 50 kilograms. It's the same for each part. And we have v squared. Okay, so in order to solve for v squared, we will have to multiply both sides by 2 to get rid of the 1/2. And then we'll have to divide both sides by 50 to get rid of the 50 over here. And so what we should be left with is v squared is equal to 490 joules times 2, all divided by 50 kilograms. And, man, the other thing we need to do is, because we have v squared here, we're going to take the square root of both sides. And so then we have v equals, drum roll please, going to use the calculator. Let's do 490 times 2 divided by 50 is equal to a 19.6. Take the square root of that number, and you get 4.4 meters per second. So if you notice, for these two problems, you had to find various things, and you had to get information from what was given to you, or from information of another energy, and so on and so forth. So all of these problems are based on calculating gravitational potential energy if you know the height and the mass, calculating kinetic energy if you know the mass and the speed, calculating mechanical energy if you know gravitational potential energy and kinetic energy. Also calculating kinetic energy or gravitational potential energy if you know mechanical energy and one of the energies. Also, you can find velocity if you know what the kinetic energy is and you know what the mass is. You could find the height if you know what the gravitational potential energy is and the mass, and you obviously know g because that's 9.8 meters per second squared always. So I hope this helps. Remembering from last year, there was a struggle with a lot of these problems. You will just give your best attempt, and you will post your best attempt to the assignment that I will create, and then I will post the solutions after that. And if you can't get them right, especially the first time, big deal. I expect to see some wrong answers. We'll get through it together, though, and hopefully by the end you will understand it. But yeah, so if you have any questions about this, obviously you know where to get a hold of me. Google Meet. You can post questions on the discussion board, email me, whatever the case may be. So best of luck in your problem solving, and I will check you later, dude.